Hello everybody. This is April 27th and we're winding down here. So just to give you an idea of the last few days is I already did all of 13.2 on the last lecture. So I don't have to do this. I'm just going to do 16.1 and 16.2 today. Then the next time we meet, it will be class review. And then Monday, May 4th is the final exam. Okay? So just to keep you posted, we've stayed on schedule. The videos are coordinating with the dates, but I already completed 13.2. And so we just have to do chapter 16 now. So actually this is my second try because the computer shut down on me and then up pops a screen which does not allow you to even save the part that you did do. So if I didn't have these challenges, this would be going a little smoother for me. So let's see. We're going forward. We're on the last lecture day, and then I will have something for you for the review as well. I'll have it for you ahead of time so that we can talk about it together. So let's look at this. We're at 16.1 and we're looking at evaluating roots. We've already talked about this. I gave you the list of perfect squares, and it looks something like this. 1 squared was 1, 2 squared was 4, 3 squared was 9, 4 squared was 16, and 5 squared is 25. And the reason it's important to look at this is because this one list gives us two pieces of information here. Is that if we go the other direction, if we take the square root of 4, it's going to give us a 2 here. If we take the square root of 9, it's going to give me that 3, which is called the base when we were doing exponents. The square root of 25 gives us 5. So that list I gave you is giving us two big pieces of information. Now, when we take the square root of 36, we get 6. And you're saying, well, what's the matter? Why don't we take minus 6? Well, the rule is you take the positive root unless otherwise designated. Take the positive root unless otherwise designated. So the square root of 144 is 12. Well, how do we designate otherwise? If we want the negative root, we put a minus sign in front of it. The opposite of the square root of 49 over the square root of 81 gives us minus 7 over 9. If we want both roots, we put a plus or a minus sign there, and that would give me plus or minus 8. So let's go over that again. We take the positive root unless otherwise designated. If we want the negative root, put a minus sign. If we want both of them, put a plus or a minus there. Looking on page 1115, number 3, the author is asking us to square the square root of 41. So what that means is the square root of 41 times the square root of 41. So what we're doing this is what the question is, this is what it means, and when we multiply a square root times itself, it is itself, becomes itself. So if we have minus the square root of 39, the quantity squared, this one's a little different. It means minus the square root of 39 times minus the square root of 39. So now minus times a minus is a plus, and we get positive 39. The square root of 2x squared plus 3 times itself is what is under the radical symbol. So you're going to use this when we're working on equations in future math classes. You need to know about rational and irrational. So we already talked about that when we were talking about numbers. Remember that irrational is going to be, it's going to come out and you're going to get a decimal, and it will be a not repeating, and it will not end and not terminate. So most of our numbers are irrational. I mean, when we would take the square root of them. For example, the square root of 9 is 3. That is rational. However, the square root of 7 is 2.645751311. It does not end. Your author asks you to round it off to the tenths. I look to the right and I get 2.6. Okay? So when we fills up our whole screen like that, that is irrational. Part C, the square root of 9 over 16 is the square root of 9 over the square root of 16, and you get 3/4. E, the square root of negative 43. Is there any number when multiplied times itself is negative 43? Absolutely no. So this is not a real number. Okay, there's no number when multiplied times itself gives us negative 43. Probably easier to understand if I pick a number that you're familiar with. For example, the square root of minus 9. You might say, well, is it 3? Is it 3? No, because 3 times 3 is positive 9. Is it minus 3? Minus 3 times negative 3 is positive 9. The answer is no. This is not a real number at all. Page 1117, we want to round to the nearest tenth. On page 1117, that is number 5. 5a, we have the square root of 28. So you put that into your calculator, everybody. You have a square root function because remember I went around the classroom and we saw that you did. You're going to get 5.2915022622 if it goes out that far. Your author said to the nearest thousandth. So tenths, hundredths, thousandths. I look to the right. The number is 5 or bigger, so I have to go up to the number 2. Okay? Part C, the opposite of the square root of 190. Well, when you put that in your calculator, just put in the 190 and you bring over that minus sign. and you're going to get 13.78404875, a large number. Round off to the nearest thousandth. You're going to look to the right, and we're going to have minus 13.784 because 0 is less than 5. Look at the triangle. I'm on the same page, 6A, and we did a lot with the Pythagorean theorem, so this is not new to you. And we're given A equal to 7 and B equal to 24, and we want to find C. So we have A squared plus B squared equals C squared. 7 squared plus 24 squared equals C squared. And 7 squared is 49. Put this in your calculator, you get 576. And when you add these two together, you'll get 625. But we don't want C squared. We want C. So if we take the square root of the left, we have to take the square root of the right. And we get C equal to 25. Looking at 6B, we're given B equals 13, and be very careful. C is 15. That's the side opposite the right angle, and we have to find A. So A squared plus B squared equals C squared. A squared plus 13 squared equal to 15 squared. Okay? So I don't have 13 on the list, but some of you use it and you know it's 169, or put it in your calculator, 225. I need the A to stand alone, so I'll subtract 169 from each side, and I get A squared is 9 from 15 is 6, you borrowed 1. 6 from 11 is 5, and that, of course, was a 1. So I want A is the square root of 56. Well, that's not a perfect square. We know it's bigger than 7 and less than 8, but we have to put it in our calculator. The author wants it to the nearest thousandth. Look to the right, and you get approximately equal to 7.483. Okay? And then number C is exactly the same as that one. We've done quite a few of them when we did the Pythagorean theorem, so you're in good shape there. Now, on 46, we want to have an idea on size. And that's an important part of math. So let's just think about this. Let's just think. If we want the square root of 43, I'm thinking, well, golly, 43 is near what number that I do know? Well, it's near 36, and it's near 49. It's between those numbers, okay? So it looks like that. So 6 is less than the square root of 43 is less than 7. So it's between 6 and 7. So that's an important thing, that you know that it's going to be 6 point something or another. Okay? Looks like that. Now, number 50 is somewhat trickier. What we need to know is we need to know our number line on the negative side. Okay? So we have negative square root of 63. So I'm thinking I know the square root of 64, which is negative 8, and I know the square root of 49, which is 7. So, but remember, as we go to the left, the absolute value gets greater. So the square of 8 is 64. The square of 7 is 49. And we have a minus sign. So this is less than this. And then we have minus, whoops, I didn't allow enough room here. This is less than the square root of 63, negative, less than negative the square root of 49. Minus 8 is less than the square root of minus 60, whoops, positive 63 is less than minus 7. So it's between minus 8 and negative 7. When you're dealing with negative numbers, draw the number line so you're going in the right direction. Looking on page, let's look on page, let's see, I want 54, problem 54. And I'm on page 1122, and we want the square root of, I want to see if I skipped something here. Nope, I didn't. 54, we want the square root of 169. So the square root is 13, and that is rational. Look at this. We want the square root of 500. Well, I know the square root of 100. I know the square root of 400. I do not know the square root of 500. If you put it in your calculator, it turns out something like this. That is irrational. And if I round this off to the nearest thousandth, we're going to get minus 22.361. Okay? So we do want to have a concept of rational and irrational. We kind of want to have an idea of size, okay? You know, I would have said, well, the square root of 400 is 20. With a minus sign, it would be minus 20. So I knew it had to be in the ballpark of negative 20. Okay, we've done quite a few of these. On 68, you have to find C. We've already done one like that. On 72, you have to find C. I like the ones where we have to find a leg, but we don't have, okay, number 70, we have to find a leg. So let's do this, and we did this in the Pythagorean theorem section. A equals 5, C equals 13, and we want B. So write the formula down, substitute in, and we get 25 plus B squared equals 169. Subtract 25 from each side, and I get B squared is 144. I need B, so I have to take the square root of 144, and I get 12. That is rational. Nothing that I'm going to round off at all. Okay? Now, look at number 76. You know, doing these little word problems is so helpful because that's what life is. We do word problem after word problem. And we have 40 and we have 9 meters. And this is the diagonal. The question says find the length of the diagonal. Well, that's the hypotenuse. So a squared plus b squared equals c squared, and we get 40 squared plus 9 squared equals c squared. 1600 plus 81 is c squared, so c squared equals 1681, and c is the square root of that. Well, that's not in our memory bank, so what you're going to do is put it in your calculator and you will get 41 meters. That is rational, okay? If we have, yes, that is rational. And it had to be the biggest length in that triangle, and it is. Okay? So now let's look at number 80. A boat is being pulled toward a dock with a rope attached at water level. Okay? So here's my dock. Here's my boat out here. And we're given, this is the rope that's attached to the dock. It's pulling it this way to go towards the dock. But this is the water level. Okay? Information. When the boat is 24 feet from the dock, 30 feet of rope is extended. What is the height of the dock above water? Perfect question. I would expect that you would be able to do that on a test. A squared plus b squared equal to c squared. 24 squared plus b squared equals 30 squared. And 24 squared is 576. I think we did that in a problem before. 30 squared is 900. How did I know? 3 times 3 is 9. I have 1 0 squared gives me 2 zeros. Subtract 576 from each side, and we get b squared equals 324. Take the square root of each side, and I get b equal to 18 feet. We need the units of measure. So that's a pretty decent problem. Problem number 34 in the book asked you for the square root of minus 64. There's no number when multiplied times itself will give us negative 64. Okay? So now we have, mostly in life we deal with squares. We don't deal as much with cube roots or cubes, but the author just has a couple of them, and it's good to have a couple of them in your memory bank. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 10 cubed is 1,000. Fourth powers, 1 to the 4 is 1, 2 to the 4 is 16, 3 to the 4 is 81. So, I mean, it would be useful if you know those. This one you should know. This tells me 3 zeros. Okay? So, it's helpful because you don't have to constantly be using your calculator. So, page 1124. The cube root of 27 is 3. And be very careful now. Remember, we couldn't take the square root of a negative number, but look here. We can take the cube root because 3 is odd. So what number? Minus 3 times negative 3 times negative 3 will give me a negative 27. Okay? And the cube root of 1,000 is 10. Okay? So that is 16.1 is a good section. It gets us started knowing a little bit about radicals and information that you're going to need as we solve more equations in Math 1100. Okay, so now we're going to do some computation. We're in 16.2 now. Let me just take a little drink here. In 16.2, we're looking at multiplying and dividing and simplifying radicals. Well, we're not going to do much. We're not going to do much in simplifying. Not much, okay? We're mostly going to be concerned with multiplying and dividing. Okay, my lights went out again. It scared me because I thought my computer went out again, and I've already done this twice. So now let's look. What we have to know is the square root of A times the square root of B. Notice the index number is the same, and that's going to give us the square root of AB. Example, the square root of 2 times the square root of 3 is the square root of 6. The square root of 7 times the square root of 5 is the square root of 35. Now this also goes in the other direction. The square root of a product is the product of the square roots of the factors. Okay, so looking at page 1131, we're going to have this. Let me see number 8. Number 8, the square root of 3 times the square root of 7 gives me the square root of 21. Number 10, the square root of 2 times the square root of 15 is radical 30. Number 12, the square root of 5, whoops, I'm off the screen here. The square root of 5 times the square root of 6 is the square root of 30 as well. So all we do is we multiply the numbers underneath the radical. We will omit 15 through 50. We will omit those. We do not do much with simplifying radicals in Math 1050. You will spend quite a bit of time on that in another class. Okay? But these are some basics here. You're getting all the basics for sure. Page 1132, number 54. The square root of 9 over 100 is the square root of 9 over the square root of 100. You want to split it up like that. Okay, and we get 3/10. You're not going to go to decimals, folks. Just going to keep it the way it is. And then 56, we have the square root of 13 over 25 is the square root of 13 over the square root of 25. I do not know the square root of 13, but I do know the square root of 5. Number 58 has a little trick up its sleeve. We have the square root of 14 over 72. I do not know the square root of 14. I do not know the square root of 72. But I see that they're both even. So why don't we try reducing first and see if that helps? So if I divide by 2, I'm going to get 7. And if I divide by 2, I'm going to get 36. So I do not know the square root of 7. But wait a second. I do know the square root of 36 is 6. So reduce first if you can. Not much in this section at all, 16:2. Let's do number 60. Number 60, what was that about? Okay, number 60, if you were here, I would ask you to do this problem, and you would say, well, I don't know either of these, but why don't I put them under the same radical? Reduce first. They're both even. 2 into a 200 is 100, and I know the square root of 100 is 10. So it's hard to remember reducing first. But you're always going to say, I don't know the way it is, the way it stands. Can I jiggle this around so I do know? So you're looking at dividing this out. On page 1132, or 3, looking at k squared, the square root here. Let's look at this. We're looking at number 66. I want the square root of k squared. So remember, square root is a 2. 2 goes into 2 evenly, and I get k to the 1. And we were given that all variables are positive. Well, he said represent non-negative numbers. So if you're given that, we were able to take that out and get that answer. 68, the square root of s to the 4. I divide 2 into 4, and I get s squared. Not too difficult. 70, the square root of 49 n squared. So we know the square root of 49 is 7. 2 into 2 gives me n. Okay? We're cruising here. These are easy for us. 72, the square root of 900 y to the 8th. So I know the square root of 9 is 3. I have 2 zeros, so how about 30? 30 squared is 900. 2 into 8 is 4. 84. The square root of a to the 8, b to the 10. These are even. 2 into 8 goes 4 times. 2 into 10 goes 5 times. 86. The square root of 100, c to the 4, d to the 6. I know the square root of 100 is 10. 2 into 4 is c squared, d cubed. 90. I have a quotient, w to the 8 over 144 is the square root of w to the 8 over 144. 2 into 8 goes 4. The square root of 144 is 12. 92. This is the square root of a to the 4 over the square root of b to the 6. 2 into 4 goes 2. 2 into 6 goes 3. We did a lot of problems. Chapter 16 was not that bad. We're going to omit 73 through 82, 93 through 100, do 101 through 109, all of them, to get enough. And then, as I said, I'm going to be, by the time you get this, I'll have all the homework listed. But it looks like that. So that was the end of our lecture. When I see you on Wednesday, then we will be looking at the review. But remember, you want to come prepared, folks. Come prepared on the review. Okay? You need to do some work on your own so that when I go over it, it's not like I'm teaching the whole class over again. Okay? So we finished all the new material. It's your job to go over it all now and to work with it. So we've done a lot of work under very difficult conditions, and I hope everything is good with you.